Hey, what's up guys? Mr. Schwarman here. Going to make this quick video to help tell you guys about trusses, give you some of the introduction, some of the basics, and so you know some of the vocab. So first, I've got some images just to show you what a truss is. All a truss is a name for a structure that is made up of interlocking beams supported at their ends in triangular shapes, because triangles are the most stable structure, the best at distributing weight. And the two places in the real world we see them a lot are in bridge trusses like this one, and in roof trusses like this one, where all these interlocking wood beams are supporting the weight of a roof, whereas in a bridge, all the interlocking, in this case steel beams, support the weight of the bridge and all the cars and railroads that go over it. And so some vocab here. We're just going to call a truss a structure made up of linked beams in triangular patterns to support weight. Like we said, most common ones we see large scale are bridges and roofs, but as you start looking around, you'll see lots of things supported in interlocked triangles because triangles are the most rigid shape. What we're going to call those beams from point to point is a member, and where the members meet, we're going to call that a joint. So if I zoom in at the bottom here a little bit, this, for instance, is a member. This, for instance, is a joint. We can see something has to be joining them, and oftentimes, like in this wood truss, it is a metal plate. Call it maybe a mending plate or a gusset plate. And this plate is here, and then all those bolts bolt into all those different wood beams to hold them together. The other way they are most commonly joined is via welds, which you can't necessarily see here, but let's assume this is steel. This is all welded together. Another thing we're going to talk about with trusses is how they are supported at the ends, what's holding them up. This truss, is a bridge truss over here. This is very, very common for bridge trusses, is something's holding it up, one at each end. So there are three common types and really two common types we're going to look at. And so these images are all from the SkyCiv website. SkyCiv is a great website. They've got a really great product. The real one costs money, but the free version is okay too. So, especially if we're looking at bridges, bridges actually need to be able to move a little bit, to flex a little bit. As temperatures change and things expand and contract, as different wind hits it, as different weights and loads are on it, things have to be able to move a little bit. If everything was too fixed, it might be too rigid. So a lot of trusses might be supported like this, and this is called a pin support. You can see right here, there's literally a big old pin. And what that means is the pin, imagine a pin, it stops anything from moving up and down, and it stops anything from moving left and right, but it does allow this truss member to rotate freely. It provides no reaction moment. However, it does provide, if we see over here, a reaction force in the y direction because it's holding up the truss, and a reaction force in the x direction. It's holding it left, right, and stopping it from, flying off to the left or to the right. Pins are represented by a triangle on a little crosshatch surface. Compare pins to rollers. Rollers are drawn with a triangle with circles, or sometimes they're just drawn as a circle and it looks like a little cart that can roll, because that's exactly what it is. This support is holding the weight of this bridge truss up and down, but it's not preventing it from moving left and right. It can actually roll back and forth a little bit. Again, this is intentionally built into trusses to allow them to flex, to move, because if they're too rigid, they might become brittle, they might snap. We're also going to see that there is a mathematical reason we will often assume that we're going to design trusses with pins and with rollers. The third kind of support that we're not going to see very often with trusses, but I want you to be familiar with, is what we call a fixed support. As we can see here, it's like this metal post buried in concrete. It stops it from moving up, down, left, and right, and it stops it from bending. So it provides a moment. So we would draw it with three reactions, two forces, a y force, an x force, and a moment. So here, let's look at this truss. Let's put all together the vocab, make sure we understand it. This is what's called a Pratt truss. This is a diagrammatic view of, a bridge truss. On one end, it's supported by a pin, and one end, it's supported by a roller. So if we go through, first we're going to count the joints. And I count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 joints. So I'll write that down. Those are the joints where the bridge members meet. Let's talk about members. How many members are there? Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and don't forget the ones up top, 18, 19, 20, 21. There are 21 members in this bridge, highlighted green. Let's look at the supports. The left, like we said, is a pin support, so there's an X and a Y direction. The right is a roller support, so there's only a Y direction in this case. So there are 3 reaction forces holding this bridge up. Now the reason we do that, the reason we count all this isn't just for fun, though hopefully you're able to count up to 21, but it's to determine something we call static determinacy. What static determinacy means is just a fancy way of saying, can we solve it by hand? Is it possible to do mathematical calculations? And for a truss to be statically determinate, this equation must be true. 2 times j, 2 times the number of joints, must equal m plus r, the number of members plus the number of reactions. And in this case, if we plug in this truss that we looked at, that would be 2 times 12, that's 24 on the left side. And on the right side, 21 plus 3, members plus reactions, 24 is 24. So this truss is what we call statically determinate. So to recap, in this video, we saw what is a truss, we saw a bridge truss, we saw a roof truss, and we saw these terms members and joints. We saw the 3 kinds of supports a truss might have, a pin, a roller, or fixed. And we saw how to find each of these things and calculate static determinacy.